Till now, you might have been thinking that shaders can be only used to make some crazy looking skies, some super cool water effects, and all of that stuff that seems pretty hard to make. Actually, shaders are easy to learn and can be used in many ways. You can create some interesting post-processing effects, add some waves to the water, make the leaves and grass sway in the wind. You can also add some interactable objects where the player can draw, so that the texture is updating, and a lot more interesting stuff. What are shaders? You have been actually using them from the first time that you have opened Unity and create the basic cube. So on the cube I have a material, and you can see that the material is already using a standard shader. So material is just giving some inputs to the shader. It is telling it how it should look like, give it some texture, what the color should be, what is the metallic, smoothness. But the material itself is just holding the data about what the shader should do. And the shader is doing all of the magic behind. It is telling the GPU how it should render the object. So shaders are really important. They are responsible for the lighting, shadows, the color of the object, and pretty much all of that stuff. Materials are just holding some information about how the shader should draw the object. So always when you want to use some custom shader, you first need to create a material for it. So how do we create shader? Just right click, create, shader, and there's many types of shaders. First shader is the standard surface shader, and it does what the name says. It is the standard shader that is handling the light, shadows, and reflections, so it is commonly used in 3D. The second shader, unlit shader, unlike the first shader, is not handling light, reflections, and shadows, so it is used in places where you don't care about the lights and shadows. The third, image effect shader, is used to apply some effects to the whole screen, so you can create effects like bloom, vignette, and so on. The fourth one, custom render texture, is used to capture specific views of the scene so that you can then dynamically render it to a texture, which can be used for example, mirrors. Compute shaders are used for non-graphic tasks, such as some physics simulations. And lastly, the ray tracing shader is handling the ray tracing for better reflections, lighting, and so on. So I will create basic unlit shader, which is not handling the lights. We'll add it to the material, so select the material, go to the shader, and because we have created unlit shader, you will find it under the folder unlit, and I called it test shader. Now as we have changed the shader of the material, you can see that also the properties in the inspector changed, and I will also apply the material to the cube and open the shader. You can see that Unity has done already some work for us. It might seem a bit scary for you, but don't worry, I will explain everything. So first, we have just the name of the shader, some folder where we want to have it, so you can create some custom folder, and then the name of the shader. Then we have some properties, which are the properties that you can actually see in the inspector. So you can see that we have a property for the main texture. We called it texture in the inspector. So the name that we see is texture, but name of the variable is main text. The type of the variable is 2D, and the default value is white. So yeah, we can see that it is called texture and it is white. Then we have a subshader, which is containing all of the passes, and the passes are actually containing the code where the magic is happening. We also have some tags for the render type, but it's nothing that we'll need to change. And in the pass, as I said, the magic is happening. So in the CG program, the code of the shader is starting, and then at the end we have end CG. Then we have some pragmas, which are telling us some kind of vertex and fragment. What does that mean? There's many types of functions built inside the shader, such as the vertex and fragment function. The vertex is looping through all of the vertices of the mesh, and it allows us to change position of each of the vertex. Down here, you can also see the vertex function, where we are just returning some position. So if we would want to create some kind of wave, we could use the vertex shader, so go through all of the vertices of the mesh, and we could change them as we want. So we can see that shaders are not only used to change the colors, but also to change the shape. So back to the debug mass, the first one is telling us that we have a function of the type vertex, so the vertex shader, and it is called vert. So here we can see it is called vert, that's okay. Then we have fragment shader called frag, which you can also see down here, and the fragment shader is again looping through all of the pixels of the thing that we are trying to render, and it is setting color for each pixel. So with that we could make some color fading, make some drawing, and pretty much anything that we would want to do with the color of these pixels. Then we have some structure, which is basically the input data. We have the position of the vertex and UVs of the vertex. I will later tell you what that means. Then we have another structure, V2F. This means vertex shader to fragment shader, which is taking some data that we want to send from the vertex shader to the fragment shader. First, the vertex shader is run and then the fragment. We can't obviously send data from the fragment shader to the vertex, so that's why we have the structure here. Then we have some variables, so we can see that we have the main texture, which we have defined in the properties. So here you could add any variables you would want. We'll begin in the fragment shader, where we'll just visualize the UV coordinates of some object. UV coordinates are from 0 to 1, they are on the x and also y axis. I will delete the fog, because we don't need that. And then we are setting some fixed 4 of color, which fixed 4 is basically vector 4. It has 4 values. And we are setting it to the texture. And from the texture that we set, we want to take a pixel at the position of the UV. So we are going through all of the pixels, we take the current pixel, and we find the position on the texture that is corresponding to that pixel, but we'll need that later. So I will just comment it. And here, using the return, we can just return the color for this pixel that we are going through right now. So we can return float 4 and then give it the values. So I could try black, which would be just like that. We are using float 4 because color has the R, G, B, and alpha. So we can try just returning the black color for each pixel. Yep, it is working how it is supposed to, just changing the color to black. Now, how do we visualize the UV coordinates? Well, you can see that we have one of the parameters of the fragment shader is the V2F, which is passing us some info from the vertex shader. And here in the structure, you can see that one of the parameters of the V2F is UV, which are actually the UV coordinates. So here, I will access the y.uv.x, so that we are taking the x coordinate and I'm assigning it to red. And for the y, we'll do the same thing, so i.uv.y. Now you might not be able to guess what will happen, but believe me, it all makes sense. And this is what we can see now. It looks pretty weird, but for you to understand it better, I will just add it to a simple quad, so 3D object, and I will create quad, so that we have just one plane, just like that. And now it might make a bit more sense. So this is the x-axis. You can see that on the left it is black and on the right it is red, because the value of the x is the greatest there. Then on the y, down it is black and up it is green, because here the y is 1. Then obviously when the x and y is on 1, it is just mixing the green and the red color and making yellow. Even though this looks cool, we'll probably not be able to use it in any real projects. So next we'll make some basic fading from white to black. I will create just a basic color, so we can return white, which is just 111, and when we multiply it by the position, so i.uv that, for example, x, so now we have just white color multiplied by the width. So on the left, where the x is 0, it should be black, and on the right, where the x is 1, it should be white. So let's see if that is correct. And you can see that we are fading from black to white. I could change it from x to y, and now it is on a different axis. Cool! One cool thing about shaders is that the resolution is pretty much infinite. So when I look at it from the distance, yeah, the resolution doesn't seem to be the best, but when I come closer, you can see that the resolution really seems to be infinite, which is what shaders do. And because shaders are run on runtime, we can make, for example, some flickering shader. So get back to the script, and instead of constantly returning the same value, we can, for example, use sine of time, which will make it go from black to white to black to white. So how do we make the sine? We just type sine of what? I will make it of time. There's already a pre-built variable for that. So underscore time. We need to use .y. Now, let's see what will happen. Also, in scene, the shaders are not constantly updating, so I would suggest you to play the game. We can see that it is now fading from white to black. But what I don't like about this shader is that it is staying black for a long time. This is because the sine value is between -1 and 1, and the color value is just between 0 and 1. So let's clamp the value. I will create new float, which will be for the sine value. Here we'll use the command to saturate, which is just clamping the value between 0 and 1. Then I will take some number, and to it I will add some other number and multiply it by the sine. If you really focus on this part, it probably makes sense. We are multiplying the sine by some small number, so it doesn't have that big of an effect to the fading, and I'm just adding some number to it so that it is not going to minus numbers. And let's try that. So input the sine value here. Yep, so now it is going from white to gray and from gray to white, which is looking better for some kind of flickering effect, but it is pretty slow, right? So for this, I will actually create some property, which will be for the flicker speed. You don't have to be naming them with underscore, but it is just a good practice. So we have variable flicker speed. I called it flicker speed. It is type of float. And now to actually use it in our fragment shader, we will also need to define it with the other variables. So float, give it the same name, so it is recognizing the variable. So the flicker speed, semicolon, just like this, we have defined a variable with a property that we'll be able to change in the material. And now we can just multiply that time by the flicker speed. So the shader is still the same, but when I select the material, you can see the property for the flicker speed, and when I change it to 10, you can see that the flickering is a lot quicker. Even though this flickering on its own is cool, but what if I want to add some interactable object, some box that the player will be able to collect? We might want to try to add some texture, so I have the box texture, just add it here, but nothing is changing with the texture. Why is that? Obviously because in the code we are only setting the color to the white multiplied by the sine value. This is why we'll use the part of the code that I have commented here, which is the texture 2D. So we'll take the pixel of the texture at the correct position and multiply it by the sine value. Can you guess what will happen now? Now you can see that we can see the texture which is flickering. Why is that? Because we are taking the correct position of the texture, so we have the correct pixel color, and we are just multiplying that color by the sine value, which is somewhere between, let's say, 0.7 to 0.9, so it is going from slightly black to white. So like this, you could create some flickering coins and other objects and change their flicker speed. What is one of the best things about shaders is that you can use one shader for many materials. So I could just copy the shader, change the texture, and I have two materials that are using the same shader, but for each one of them I can set different flicker speed and different texture. But this is just one of the ways how you can use shaders. This shader is pretty simple. You could also do it just by changing color of the sprite renderer that you would have on the object. Another thing that we will do next is to just generate some dot in the texture, which might be a bit harder to do without shaders, right? Let me show you how to do that. So I created new material along with new shader, which is again the unlit one, and I have just assigned the shader to the material, and after a while I will show you what is inside the shader. But what it does is that I can set position, and you can see that it is setting position of the dot on the texture that I set here. I can also set the size of the dot and so on. So this could be used for some kind of drawing that you want the player to be able to draw on some objects. It can also be used for any other stuff. So yeah, it might seem like nothing too fancy, but because it is all running at runtime, you can also change the position of the dot through script, which I will show you after a while. The resolution of the dot is infinite, so I can zoom in as much as I want, and it is still staying in a perfect resolution. And because it is all using shaders, it is running on the GPU, so it is a lot quicker than running it in a normal C# script. Now, how does the shader itself look like? I have defined two variables, or properties I should say. First one is for the position. It is a vector, because you can't directly define, for example, float2, which is like a vector2. So I have the position, the size, setting the default volume. I have also set the variables so that I can use them in the fragment shader. And in the fragment shader itself, I'm using a command for distance and checking if the distance between the current pixel that we are going through in the fragment shader and the position of the dot is greater than the size. If this is true, I'm just returning the correct point on the texture. Otherwise, I am returning white, which is color of the dot. So this is all of the magic behind this shader, nothing too complicated. Now, how would we be able to control the position of the dot through a C# script? It is actually pretty simple. So creating C# script, we'll need to have a reference for the material. So serialize field, material, I will call it mat. And in update, we can just set some properties. So we can do mat dot set vector, because the type of the variable is vector. And what is the name of the vector? It is position. To which value I want to set it? I want to basically take the current position and just add some input if I'm pressing any keys. First, we need to create the move vector. This one has to be vector 4 because we want to add the position, which is also vector 4, to the move vector. So I'm creating new vector 4, getting the input axis of the horizontal, the input axis of the vertical, then just setting these two values to 0. I'm setting vector on the material, which is named position, to value of the current position plus the move vector. So it is pretty simple. This way you can do it with floats, textures, and all of the other variables that you have in your shader. And because the movement will probably be really quick, I will just multiply the move vector by some small number. Don't forget to add the script and assign the material. And now, as I'm pressing WASD, you can see that I'm able to move with the dot, which is made using a shader, and we are controlling values of the material that is using that shader through C# code. Now I will tell you the biggest advantage of using shaders, and it is their performance, because C# scripts are running on your CPU, shaders are running on your GPU. So what is the difference here? GPU is basically hundreds and thousands of your CPUs. They are not as powerful, but they can all be running simultaneously. So this gives us a huge performance boost when working with some textures, moving some vertices and so on. Now you are maybe asking me, well, how big is the difference? Is it like 2 times? No, it is 10 times. Don't you believe me? I have two quads, which have pretty much the same logic. They are just fading from white to black to white and so on. So first I have the shader one. Right now you can see that we are sitting at 800 FPS. When I turn it on, we are still about somewhere 700 to 800 FPS. The shader is correctly fading, and it is doing all of the stuff that this shader is supposed to do. Now let's say that you would want to do the same thing in C#. So I will turn off the shader and turn on the C# one. And you can see that I have about 90 FPS in completely empty scene, which really is bad result. So you can see that the shaders are 10 times or more worth using. It obviously depends on the use case. Now I will just quickly show you the code that I made in the C# one, so you know why is it that slow. Obviously in this case we don't have to be changing each pixel of the quad, But if you want to make something more crazy, you should really use shaders and not C#. Because what is the problem here? I'm creating texture which is 300 by 300. This seems okay. But how do we change the pixels? We first need to take all of them into array, and then we need to loop through this whole array, which is 300 times 300 big, which is really a lot of calculations that need to happen at the same time on the CPU. Then I'm just having the same logic. I have the color.white multiplied by the sine of time and assigning this value to the pixels. I hope that from now on you will be using shaders a lot more, because they can increase the performance, you can make some nice post-processing, and some other effects that you would not be able to do using just classic C#. And if you are still not sure how to use them, you are maybe thinking of creating some water, some leaves, some basic kind of force field effects and that stuff, you can be looking forward to my next videos where I will be just focusing on some specific shaders and how to make them. I hope that this video was useful. If you have any questions, drop them down to the comments. Don't forget to like, subscribe, and I will see you in next videos. Bye! Thanks for watching this video till the end. If you are looking for a Unity, C# or Bolt tutor, then I am here for you, so feel free to send me a message to my Gmail and take a look at my website for more info. I can help you with your personal projects or teach you anything about game development you would want to know. You are welcome.